Welcome to our talk on carbon dioxide. When I began to do my research on my book on climate change, there were a number of things that were immediately obvious. The first one was that it didn't matter which aspect of climate change we decided to talk about, whether it was rising temperatures, acidic oceans, melting ice sheets or disappearing polar bears. The culprit in all of this, the accused, was always carbon dioxide. Everything in the climate change debate revolves around carbon dioxide. The next thing that was apparent was that when I spoke to the protesters and those who cared deeply about our climate, they were quick to tell me that the science is settled, that the evidence is overwhelming, the proof is overwhelming, it's undeniable. So when I was confronted with this, I would say to them, well, can you please show me a couple of these scientific papers that present this overwhelming evidence, because I'd love to read them. But you know, in amongst all of that, not one of them came up with a single scientific paper. Sure, they came up with statements from prominent environmentalists or alarmists, but statements are not evidence. And many, many times they would quote to me the theory about 97% of scientists have agreed that the planet is warming and humans are responsible. But the amazing thing that I found about that is that not one of them seemed to have any recognition of the fact that they were parroting something that had long since been discredited and shown to be a furphy. I can only conclude that the average climate change enthusiast is driven more by blind faith than hard evidence. Now, those of us of our vintage, or my vintage, will remember back to the 1970s, because back then we were told about the oncoming ice age climate crisis. We were told during the 1970s that the globe was cooling, and this was the dominant narrative on climate throughout the 1970s. There were numerous articles in many exclusive newspapers and magazines, Newsweek, National Geographic, New York Times, all of these articles. There was many climatologists telling us we were going to freeze to death, that it was coming. Of course, when we look back now, it's laughable. And the interesting thing is, when we talk to the climate alarmists about this, they tend, these days, they're a little embarrassed about it. And they tend to say, well, that was just a media hype, media build-up. But for those of us who lived through it, we remember very well it was presented as a real crisis. Another interesting crisis that happened in the 1970s was we were told in no uncertain terms that we'd reached peak oil and that fossil fuels were drying up. The wells were being depleted, there was not enough new wells being found, and that this was going to affect our lifestyle, our industry, our transport. And you know, that was 50 years ago. 50 years ago. And how ironical is it that here we are 50 years on, and we're now being told that there's so much of this fossil fuel around and we're pumping it out into the atmosphere and creating all this carbon dioxide at such a rate, we're in fear of manufacturing our own extinction. So folks, is it any wonder that some of the older generation are a little sceptical about the current crisis on climate? Another thing that was immediately apparent was the fact that many of these climate alarmists could not answer the simplest of questions about carbon dioxide. Like, for instance, how much carbon dioxide occurs naturally in the atmosphere? Didn't know. Why is CO2 a greenhouse gas in our atmosphere and other gases aren't? Tell me why CO2 isn't essential for life on Earth. Now, they were very good at telling me that CO2 is a villain, a pollutant. It's going to cause all these predicted problems. But really, if they are so convinced about the issues with carbon dioxide, you would think the first thing they would do is get to understand it. If you're going to solve a problem, you must understand it. But of course, that's become increasingly difficult, because anybody who wants to normalise CO2 or talk about it from a strictly factual point of view is attacked. It's become an emotional issue. In the words of Dr. Robert Fagan, who is the noted Australian geologist and climatologist, he said, when referring to the direction that the climate debate has taken, and I quote, he said, "A scenario is playing out today where serious scientific investigation and analysis have been abandoned and replaced with woefully inadequate understanding of the basic science involved. Poor science and even poorer scientists have captured the debate." There is a major obstacle here that needs to be rectified. The core of the climate change debate all revolves around carbon dioxide. CO2 is the accused enemy. Therefore, we have to start to rectify this problem with the simplest analysis of what CO2 is and how it operates in the atmosphere. So the place to start is with the physical and chemical properties of carbon dioxide. Now here's a chart that lists some simple physical properties of carbon dioxide. I'll run through them very quickly. CO2 is a gas molecule which consists of one carbon atom and two oxygen atoms. CO2 occurs naturally as a trace gas in the atmosphere at a concentration of 0.04%. It's presently about 400 parts per million. It's said to be heavier than air, invisible, odourless, colourless, tasteless, does not support combustion and is soluble in water. CO2 is produced naturally via the decay of organic materials, combustion of wood, volcanoes, hot springs, decay of carbonate rocks. CO2 liquefies under pressure, and when frozen, it is called dry ice. So it's a perfectly normal trace gas in our atmosphere. It is not some foreign toxic pollutant. And if you have ever walked during your lifetime under a rainforest canopy or sat in a crowded auditorium, you would have been breathing in carbon dioxide at a level roughly between 800 and 1,000 parts per million. It is not a dangerous gas. According to the US Occupational Safety and Health Administration, adult exposure should not exceed 5,000 parts per million. That's what the submariners work on. That's 12 to 13 times higher than the current levels in our atmosphere. We've now had a quick look at the physical properties. Let's have a look at the practical properties of CO2. Because carbon dioxide has many practical uses. It's used as a refrigerant in air conditioners, dry ice. That's a good one, dry ice, because when it melts, it doesn't make liquid and make things soggy. It goes off as a gas. CO2 is used in soft drinks and soda water and beer and champagne, and every time you have a drink of a sparkling liquid, that's carbon dioxide that you're drinking. The bakers use it in their yeast, in baking soda, dry cleaning, pop rock candy. When you put that candy on your tongue and it fizzes, that's carbon dioxide that's fizzing. It's used in the process of caffeine removal. In the welding industry, it's used in air guns and paintball machines. It's used as a compressed gas for many pneumatic tools, even in life jackets. It's used in the oil recovery industry to help thick oil become more viscous. It's used in the production of urea fertilizer, one of the main fertilisers used around the planet. It can be used as a fumigant. It's used in animal stun guns, and commercial greenhouses, of course, they induce or produce high levels of carbon dioxide to get the extra plant production, and it also conserves water in their greenhouses. So they pump the carbon dioxide up to around 800 to 1500 parts per million. But it doesn't stop there. CO2 has very essential medical uses. 5% of CO2 added to pure oxygen for breathing stimulation, particularly in apnea patients. Of the CO2 that we breathe in from the atmosphere, 70 to 80% of it ends up in our red blood cells, 5% dissolves in our plasma, 5 to 10% is bound to hemoglobin to assist the oxygen-carrying molecule in red blood cells. It is the CO2 within our bodies that regulates our breathing. When we do heavy exercise and we say, oh boy, I've got to sit down and suck in some oxygen, your body doesn't know to do that from lack of oxygen. What it detects is the different levels of CO2, and then we breathe faster. Besides the many practical uses of CO2, we have the essential uses. Now here's a chart that lists a few of the essential uses. Atmospheric CO2 is a primary source of life on Earth. After all, without CO2 there would be no plant life. Without plant life there would be no photosynthesis and therefore no oxygen. Without oxygen there would be no animal life, including human life. The three essentials for food production are water, sunlight and carbon dioxide. Photosynthesis enables carbohydrate production. Carbohydrates are the basic food for living organisms. The carbon in carbohydrates is almost all derived from atmospheric CO2. Dissolved CO2 in the ocean is used by shellfish and coral reefs. All greenhouse gases, including CO2, helps warm the Earth's temperature by an average of 30 degrees. That's what we're told. Of course, of that 30 degrees, water vapour supplies between 75 and 90%. We are so often frightened about CO2. We need to remind ourselves that CO2 is this planet's gas of life. It really is the breath of life. It is essential to our very existence, and it has wonderful practical uses in our everyday lives. Now let's answer a couple of the earlier questions we posed. Why is CO2 a greenhouse gas while other gases in the atmosphere are not? CO2 is comprised of three atoms. All of the greenhouse gases have at least three atoms. Now when the sun beats down on the Earth, the sunlight passes right through the atmosphere. But when it strikes the Earth, it heats the Earth. And some of that heat is re-radiated up in the form of infrared radiation. The CO2 molecule has the ability to absorb particular bands of infrared radiation. It takes on what's known as a photon, which is an electromagnetic radiation particle. And when it takes on this extra energy, it vibrates. And vibration causes heat, and it bumps into each other and it passes the heat around through conduction. There are several gases that cause greenhouse warming. By far, the most effective warmer in the atmosphere is water vapour. As I said earlier, between 75 and 90%, depending on the location and the time of year where it's measured, etc. CO2 is the next biggest warmer. It contributes about 20% of the planet's warming. There are a number of other gases that contribute to the remainder. Of course, the concentration of these gases can vary, just depending once again on location. Now here's another question that we posed earlier. What percentage of our atmosphere actually comprises CO2? And I can tell you the accepted figure is 0.04%. Now we know that that's not much, but let's just think about that for a minute and get some real perspective on it. So let's imagine that we have a pile of 10,000 apples. 10,000 apples in a big pile, probably a metre or two high, a metre or two wide. Now I want you to take 4 of those apples and put them to one side. What you have there now, if those 10,000 apples represent our atmosphere, the 4 apples you've put to one side represent all of the carbon dioxide in that volume of atmosphere. 4 apples out of 10,000. But you see, that's not the end of the story. What I want you to do now is to realise that carbon dioxide occurs naturally. So what percentage of those 4 apples that's up there in the atmosphere are humans responsible for? Well, to get a visual on that, you have to take those 4 apples, cut each one into 25 pieces. That's 100 pieces of apple, and you take 2 of those pieces. 2 pieces, that's round about 1/12 of one apple out of 10,000. And that is the amount of CO2 we're told that humans eject into the atmosphere. You're starting to get some sort of perspective on the amount of CO2 we're talking about. But we can take it even further. Let's look at Australia. Of those 2 pieces, how much is Australia responsible for? So you have to take those 2 pieces of apple and once again cut them up until you've got 100 pieces of apple. Now you might end up with something as big as perhaps a grain of rice or 2 grains of rice. Now that is the amount that Australia is responsible for pumping into the atmosphere. 2 grains of rice out of 10,000 apples. So that's what we're dealing with here. It's certainly not a lot. And to take yet another step, when we think about Australia, we produced a lot of food and a lot of energy for other nations. So when we're out there ploughing the ground and growing the wheat, etc., and putting the fossil fuel into the air, we are picking up the account. These other nations, they can receive that food and that energy without upsetting the carbon balance. So we are picking up the account for their, what should be their emissions. In actual fact, we're about number 12 on the scale of per capita carbon emissions. But when we get it in perspective, we're not doing a bad job really. One final point that needs to be said is that if Australia disappeared completely under the waves and never again emitted 1 molecule of carbon dioxide, the amount of difference it would make to the temperature or the temperature of the planet would be immeasurable. So why on earth are we beating ourselves up with higher electrical prices when it makes no difference whatsoever? It's interesting, folks, to take a look at which countries are the culprits emitting all this CO2. Now here's a chart, it comes from Wikipedia, CO2 emissions by country. And there we have it. China's up the top, 29.4%. US, 14.3%. That's less than half what China's putting out. Europe, 9.8%, India, 6.8%, etc. Down we get there to Australia, 1.5%. And it should be said that China is designated by the United Nations as a developing country. So as such, China cannot be pressured to curb CO2 emissions. Places like India and Southeast Asia have risen their standard of living by the use of coal-fired power. So they have no interest whatsoever of giving that up. Now also on this chart you'll see coal power generators by country. Now there we are with China. They have 2,363 operating coal-fired power plants. Not only that, they're building almost another 1,200. India has 589 operating, and they're building nearly as many again at 446. Japan's got 90 operating, they're building another 45. Europe 468, building 27. There's Turkey with 56, and they're building more than they've got, they're building 93. And down the bottom we have Australia with 18 operating power stations. And how many are we building? Well, we're not building any. In fact, at least 12 of those 18 are scheduled for decommission. In reality, there are 78 countries using coal today, up from 66 in the year 2000. And since the year 2000, global coal-fired power capacity around the globe has doubled. We are told many times and oft by the Intergovernmental Panel on Climate Change that if we keep putting these CO2 levels, we're going to cause our own extinction and the planet temperature is going to rise, that there's this correlation, as they call it, between CO2 and rising temperatures. So let's deal with the CO2 temperature correlation. Here we have an article put out by the Principia Scientific International. The headline to the article reads, 500 million years and no link between atmospheric CO2 and temperature. The red line is temperature, the green line is CO2. That's for the last approximately 425 million years. When we study this graph, 4 points are very clear. There is no correlation between CO2 and temperature. Temperature troughs often occur during CO2 concentration peaks. Historically, CO2 can be seen to be normally way higher than it is today, and the lack of correlation proves conclusively the ineffectiveness of CO2 as a driver of climate change. In the conclusion to his paper, Davis says this. He says it demonstrates that changes in atmospheric CO2 did not cause temperature change in the ancient climate. Davis further concludes, there should be no more doubt regarding the ineffectiveness of atmospheric CO2 to control or drive climate change. It is simply nothing more than a bit player whose influence has been completely overestimated by climate alarmists. This next chart reveals that our plants and vegetation are actually starving for CO2. Most of planet Earth's history for the last 600 million years has CO2 levels way above present day. The horizontal line that's dotted near the bottom of the page on the graph represents present day levels. During the Cambrian period, this is the second period from the left, there was 8,000 parts per million. That's 20 times higher than today's CO2 levels. Please notice the fine line just underneath the dotted line. This represents a CO2 level of 150 parts per million. If CO2 drops to that level, then all life on Earth will die. No plants, no oxygen, no life. This, my friends, is the mass extinction level. And during the glaciations period, about 2 million years ago, we got as low as 180 parts per million. That's just 30 parts per million above planetary extinction. With present levels at just 400 parts per million, we are a lot closer to extinction from lack of CO2 than we are getting into trouble with excess CO2. Frankly, as far as plants are concerned, we are experiencing a CO2 drought because our plants evolved during a much higher atmospheric concentrations of carbon dioxide. We, of course, always should be vigilant and aware as to how our planet is being treated. But it is so ironical that while alarmists are panicking about excess CO2 causing our extinction, it was actually the lack of CO2 that brought our Earth to within a hair's breadth of extinction. You know, folks, it's commonly believed that the more CO2 you put into the atmosphere, the hotter and hotter it's going to become, that there's a direct correlation. But in actual fact, the relationship between carbon dioxide and the atmosphere is a lot more complicated than that, for the very good reason that carbon dioxide has what's known as logarithmic properties. Now, this is almost never mentioned or talked about, though it is a very important property and it is accepted throughout the scientific community. Now, here's a chart on the logarithmic properties of CO2. This graph on the warming capabilities of CO2 in the atmosphere has a vertical line which is temperature and a horizontal line which is carbon dioxide parts per million. Most of the warming done by carbon dioxide in the atmosphere is done by just the first 20 parts per million. Those first 20 parts per million can raise temperatures towards 2 degrees centigrade. But if you add another 20 parts, then the temperature does rise, but only 0.4 degrees centigrade. Add a further 20 parts and the temperature only rises 0.2 degrees centigrade. So the more you put in, the less correlation there is, the less direct correlation. Once you reach today's levels of CO2, that is 400 parts per million, then the addition of any extra CO2 is almost meaningless. Its warming effect on temperatures is so small as to be irrelevant. Once CO2 reaches a certain level, then its ability to absorb photons from certain wavelengths of infrared radiation becomes, for want of a better word, saturated. And there are simply not enough photons available for CO2 to absorb. If CO2 did not possess this property, then, according to climate alarmist theory, the planet would have cooked millions of years ago when the CO2 levels exceeded many, many thousands of parts per million. CO2 is already absorbing almost all it can. We need to get our heads around this. It's very important. CO2 only soaks up its favourite wavelengths of light, and it is close to saturation point. It manages to grab a bit more light from wavelengths that are close to its favourite bands, but it can't do much more because there are not enough leftover photons at the right wavelengths. As CO2 levels increase, it has less warming effect. Interesting, isn't it, that we never hear this sort of information? Now, generally, the global warmists say as little as possible about this sort of information. But when pushed, they will come up with the theory that CO2 in the atmosphere, or extra CO2, will rise higher. And it gets into higher levels of the atmosphere, and this tends to negate the logarithmic effect. Mind you, CO2 is heavier than air, and it tends to hug the ground. But to be fair, yes, wind currents do take some into the higher levels of the atmosphere. But of course, the higher we go in the atmosphere, the greater the expanse, the greater the volume for any gas to fill. So CO2, of course, gets very, very diluted. But here's an interesting thing. Since CO2 levels have been rising, the temperatures at higher levels in the atmosphere, that is above, say, 20 kilometres, the atmosphere up there has been cooling. For example, at 50 kilometres height, the temperatures have been estimated to fall between 5 and 10 degrees centigrade. Science magazine, November the 10th, 2009, ran an article on this, and here's an extract. There's the headlines. CO2 is a coolant in the upper atmosphere. It's worth quoting. But in higher, thinner layers of the atmosphere, the increased carbon dioxide has a cooling effect by improving these layers' ability to emit heat radiation into the void of space. Just as in lower atmospheric layers, carbon dioxide molecules here can release energy they absorb from jostling as radiation. But at these heights, photons released like this, travelling at infrared wavelengths, have a good chance of escaping directly back into space. There's not much around to absorb them. Thus, the cooling ability of these higher levels is enhanced by increased carbon dioxide. Now, this was also picked up by NASA on their website, who ran an article about events between the 8th and 10th of March 2012, which supports this cooling evidence. During that period, the biggest surge of infrared radiation for 7 years hit the upper atmosphere, and here's what happened. For the 3-day period, March the 8th through to the 10th, the thermosphere absorbed 26 billion kilowatt hours of energy. Infrared radiation from CO2 and nitrous oxide, the two most efficient coolers in the thermosphere, re-radiated 95% of that total back into space. The geometric storm dumped enough energy in the atmosphere to power every house in the Big Apple for 2 years. The majority of it has been sent back into space by the actions of CO2 and nitrous oxide. Carbon dioxide and nitrous oxide are the Earth's natural thermostats. Now, these days, of course, CO2 is blamed for all manner of extreme weather events. Hot summers, cold winters, cyclones, floods, droughts. Of course, the latest one in Australia is the bushfires. Now, the alarmists are forever telling us they're driven solely by science, that it's all settled. But actually, there is not one skerrick of evidence to support the extreme weather events. The US, I found in my research, is the best place to check out what's happening with the weather, because they've got good records and they're easily available. And those graphs show quite clearly that the recent extreme weather events are within normal parameters for intensity and frequency. You know, it pays to remember that most people experience an extreme weather event. It's a frightening moment. It's here, it's now, and it's life-threatening. And it probably is unprecedented for them personally. But when we look at the longer term, it mostly tells a different story, that these events are all within the long-term parameters. Now, climate change people often produce graphs, but those graphs are normally for a limited time period. And that, sure, they will show an increase in the number of cyclones or the number of droughts or floods, but they are cherry picking. And this is misleading. Weather averages or parameters must be assessed over the longest possible time. Anytime there is a short-term graph, it is designed to be biased. Extreme weather events do cause a lot more damage these days. That is uncontestable. But it's not because of their intensity or their frequency. It's because there's a lot more people, there's a lot more buildings and infrastructure in the path of these events. So where is the science? Where is the actual science? Where is the proof that an extra 50 molecules of carbon dioxide per million can cause the weather to do these extreme things? Because that really is what they're suggesting. If you got those 50 molecules and took them away, well, that cyclone wouldn't have happened. I mean, that is really the bottom line of what they're saying. And when you think about it, it is beyond any person's reasonable imagination. For several decades, scientists have been using ice cores as a time capsule to study the ancient atmosphere. Now, what they do is they drill down maybe 3 kilometres or more, and they then examine the gases trapped within the ice. And they then draw conclusions about the makeup of the atmosphere and temperatures and etc. And they can take these ice cores back to, more than 400,000 years. The good thing is that as they've continued to do this, their techniques have improved and their interpretation of what actually went on has gotten a lot more accurate. And because of this, there's been some quite unexpected surprises emerge. So I'd like to talk for a moment about what's known as the Vostok Ice Core Temperature and CO2 Study. Now on this chart, this is an article that ran in CO2 Science in 2003. And the headline is, Ice Core Studies Prove CO2 is not the powerful climate driver alarmists make it out to be. Now you can look this up, the address there is available. I will just deal with the conclusions that I've highlighted. And the first one there is the CO2 decrease lags the temperature decrease by several thousand years. So that's completely back to front to what the climate alarmists are telling us. The next one, shifts in the air's CO2 content lag shifts in the air temperature by approximately 900 to 1200 years. So once again, that finding is back to front. That's at the Antarctic Taylor Dome ice cores. Now the scientists were so puzzled about this, they decided to try a different measuring method, a technique called the isotropic composition of argon. But these were the conclusions. The CO2 increase lagged Antarctic deglacial warming by 800 years, plus or minus 200 years. And they said this confirms that CO2 is not the forcing that initially drives the climatic system during deglaciation. And the article concludes with this striking statement. In consequence of the several observations, the role of CO2 as a primary driver of climate change on Earth would appear to be gone, while the CO2 amplification hypothesis rings mighty hollow. You know, the global warmers often say, you often read this, that the real signature of greenhouse warming is the increasing temperature in the middle troposphere. That's about 5 kilometres up. We do have very good satellite data on temperature at that level, but the temperature is not detecting any rise in temperature. And according to Dr. Ray Spencer of the University of Alabama, who makes it his job to study all of this data, and he's done a study of the troposphere above Australia, and he found that between 1978 and 2018 there was just 0.001 degrees of temperature that has risen. Now folks, that's about as close as you can get to having no change whatsoever in the troposphere. So once again, the global warmist and alarmist predictions of what's happening is not being evidenced by real science. Now the climate alarmists are also convinced we're in dire straits because with all this CO2 in the air, it's going to devastate our oceans. It's going to turn our oceans acidic. So let's examine this concern. Now when CO2 dissolves, it does dissolve into water and it forms an acid, carbonic acid. That's the sparkly drinks we talked about earlier. And the alarmists are quick to frighten us that with this increase of carbonic acid, it's going to turn our oceans acidic. Now the ocean is normally, its pH is somewhere around 8.2, depending on where you measure it, seasons, etc. The interesting thing is that this whole acidic ocean is an exaggeration. Because even if the temperature is warming, even if the oceans take on more CO2, they are never going to be acidic. Now, they may be less alkaline by a smidge, but they are never going to be acidic. But I guess they tell us that the oceans are going to be more acidic when the correct terminology is the oceans should maybe less alkaline. So what they're doing is trying to scare us with this frightening acidic scenario. But you know, here's a very interesting point to ponder. If we go back to the Cambrian period, that's about 520 million years ago, the accepted level of carbon dioxide in the atmosphere is most of them say between 5,000 and 8,000 parts per million. I've read reports where they suggest 15,000 parts per million. If we go back to that time, the funny thing about the oceans is that is exactly the same time that the scientists tell us there was an explosion of life in the oceans. All of these fossils miraculously appear during that time when we're told by good science that our atmosphere was polluted with up to 9,000 parts per million of carbon dioxide. Alarmists are always telling us that the warmer oceans are going to kill the coral. We're terribly worried about the Great Barrier Reef. But the most prominent scientist who spent a lifetime, more than 40 years, studying the Great Barrier Reef is Professor Peter Ridd. He is the Australian authority. And he actually says the reef's doing fine. He says the reef has cycles, that it can bleach and it can recover. And as far as the ocean being too warm for coral to live, when we look at other reefs around the world, say in New Guinea or Indonesia, where the temperature is actually a degree or two warmer than Australian waters, the corals are doing just fine. You know, the ocean has its own way of doing things. Most of us don't realise that only 20% of the oxygen on this planet comes from land plants. Only 20%. Where does the rest come from? It comes from the ocean. It comes from the microscopic plant known as plankton. And plankton operates photosynthesis like any other plant. So if there's going to be more CO2 in the air, it's going to be more vigorous and produce more photosynthesis and more oxygen than ever before, like any other plant. Some of this plankton, of course, at the end of its life cycle will die, it will sink to the bottom of the ocean, it will be trapped in the sediments, and therefore that carbon will be taken out of the cycle. Now here's a map. It's a CSIRO satellite map. And what it does is it shows the increased growth in plants due to higher levels of CO2. On a global level, the planet is greening up enormously. The darker blue and greens indicate increased vegetation from higher CO2 levels. The planet is certainly greening up. Remember, our plants evolved under CO2 conditions many times higher than today's level. Today's plants are literally starving for CO2. That's why commercial greenhouses elevate CO2 levels to about 1,000 to 1,500 parts per million. Bigger and healthier plants will act as an efficient carbon sink and be an economic boost to many of our farmers' crops and global food supplies. The CSIRO, on the strength of their information on the satellite map, is saying that the planet at this stage is greened up on average about an extra 20%. Now this next chart is quite an interesting one because you can clearly see the increased plant growth from different levels of CO2 in this experiment. Plant growth has doubled at CO2 levels double today's levels. CO2 is in fact a gas fertiliser for all plants around the globe. it has enormous advantages for food production. The other major spin-off from increased CO2 levels is that plants need much less water. Water losses through leaf transpiration is reduced because they can get the CO2 they need much more quickly and efficiently. We're also told regularly by the alarmists and protesters about climate change that our planet is suffering unprecedented high levels of CO2. This anthropogenic or human-produced CO2 from fossil fuels is taking the Earth's temperature into never-before-experienced zones. Perhaps it's best to let the Encyclopaedia Britannica answer that particular one. Now here's a quote directly from the Encyclopaedia Britannica, and it says this: "In the last 600 million years, the Earth's climate on a planetary scale has been much warmer than it is today. At such times there are no ice caps near the poles, the polar seas are open, and there are no glaciers on even the highest mountain ranges. The picture of a relatively warm, ice-free planet applies for 95% of the geological past." Well, with all this talk of CO2, we've been rushed into setting CO2 targets, and we've been sold on the virtues of renewable energy. So let's pause for a moment and have a look at this next chart that deals with this. Now, this information, once again, comes from Wikipedia, and it's the world energy supply for 1915. When we look at it, oil supply is 33%, coal 30%, natural gas 24%, hydro 7%, nuclear 4%, and there's renewables at 2%. After all of the billions that have been spent on renewables, we're on 2%. I reckon it's better described not as an energy source, but as miscellaneous. The US Energy Information Administration, a body heavily relied on for scientific guidance, has announced by 2040 the projected world energy usage will increase by 28%. Fossil fuels will still account for more than 3/4 of world energy consumption through to 2040. So renewables can't do it. They can't even keep up with the increasing population. But political parties wish to curry favour with the uninformed environmentalists, so they've started to set these carbon targets. The popular one in Australia is that Australia is going to be carbon neutral by 2050. In reality, it is nothing more than virtue signalling. It's designed to pull in the uninformed environmental vote. You know, politicians, they're very clever at setting targets for other politicians. We know about their forecasts by looking at the budget. It only goes 12 months ahead, very seldom adhered to. Setting targets 30 years in advance is frankly a fraud. The developing world is entrenched with coal-fired power, cheap coal-fired power. Global CO2 neutrality is a myth, and I think at this stage what we should do is have a little summary of what we've mentioned during this talk. So here are some dot points. Why do we need carbon dioxide? Well, CO2 is a primary source of life on Earth. All plant life relies on CO2. Earth's oxygen production depends on CO2. CO2 is the primary producer of food for all human and animal life. The human body can't live without CO2 in the bloodstream. CO2 occurs naturally. It's not a pollutant. It's not poisonous. CO2 helps keep our planet at a comfortable temperature. What does more CO2 mean? Well, we've now discovered that higher CO2 levels mean faster plant growth using less water. That vigorous plants means more food production. CO2 is the best and cheapest way to fertilise and green up the planet. And it eliminates the very distinct possibility of life extinction from lack of CO2. And then there's a couple of dot points on what CO2 won't do. Higher CO2 is not an extinction threat. CO2 is not capable of causing catastrophic warming. Heating from CO2 is limited by the logarithmic effect, and CO2 is not the primary driver of Earth's climate. The primary driver always was and always will be the sun. CO2 is certainly the gas of life, the breath of life. Truthful global warming evidence has been submerged in a tsunami of bad science, political posturing, and manufactured global consensus. No problem can be solved. No problem can be solved without the currency of truth. Unfortunately, this has not been happening with climate change. Those speaking the truth are being discredited and victimised. And in the words of George Orwell, who very wisely once said, "The further a society drifts from the truth, the more it will hate those who speak it."